Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, we are going to work on the hyperbola. Now, this is my fourth lesson in our section for conic sections, and these are going to be the exact same notes that I gave to my students inside of the classroom. So what we're going to do is work on the exact same elements that we kind of worked on for the ellipse and the parabola, but you can see we're going to have a little bit different vocabulary here. We're going to have the transverse, the conjugate axis, and we're also going to include some asymptotes. Now, what's remaining the same is the vertices, co-vertices, foci, as well as being able to write and graph the equation. Now, we're not actually going to practice graphing, but I will give you kind of all the tools and information that you will need to know to be able to graph a hyperbola on your own. So let's go ahead and look at the standard form of a hyperbola, so therefore you can see how it relates to what we have already previously gone over. Now again, in our first section for classifying conic sections, we actually already covered these. So the main difference here between these two equations is it looks like an ellipse, but the difference between that is now we're finding the difference between these two rational expressions rather than the sum. The h and the k is still going to represent the center. A is still going to be your distance from the center to your vertices. B is still going to be the distance from your center to your co-vertices. And C is going to be the distance from your center to your foci. Now, the interesting thing about a hyperbola here, if you look at this, is the hyperbola looks like it is two parabolas kind of facing away from each other, right? So remember from a parabola that the parabola always opens up towards the focus, right? So you can see that both of these, where'd my thing go? You can see that both of these parabolas open up towards the foci, right? They're always open up towards there. And again, the center is going to be the midpoint of the two vertices as well. I'm sorry. Yeah, it'd be the midpoint between the two vertices as well as between the two foci. Now, the co-vertices is not really as important in this as it was like on the ellipse, because you can see that the co-vertices actually do not lie on the hyperbola at all, right? They're just going to be dots. Now, I wouldn't say they're not irrelevant. I'm not going to have my students go ahead and find them because, I mean, obviously it's just the opposite directions here. But the important thing that you can see here is if you draw a box with the vertices and the co-vertices, and then you connect the corner to corner, that's actually going to be the asymptotes of the hyperbola. So if you did need to graph the hyperbola, then that's what I'd want to do. I'd kind of create this little graph here, this little rectangle, so therefore that you could understand how to go ahead and, so you would understand how to go ahead and draw the asymptotes from there. Now, there is an equation for the asymptotes, which is fairly simple, but a lot of students will kind of get it mixed up. And you can see I have it here, y equals plus or minus b over a times x minus h plus k. So that is going to be the asymptote equation. And again, the parabolas, remember guys, approach the asymptotes. Now, I didn't do a really good job. It looks like my parabola or my hyperbolas are going away from it. But again, if you were to draw these correctly, they actually would be approaching those asymptotes as they expand to the left and to the right. The last thing I just want to kind of mention here is instead of the major axis, we call that the transverse axis. But just like the major axis for an ellipse, the vertices and the foci all lie on that transverse axis, whereas the co-vertices lie on what we call the conjugate axis. So you can see there, it's the same kind of thing with major and minor axis that we talked about for an ellipse. Also the thing that you can recognize is that they are perpendicular, and also that they intersect at the center of the hyperbola. Now, really the only difference here, and also we have eccentricity. Remember for hyperbola, eccentricity is going to be larger than 1, right? But again, that's going to be that ratio of C over A. And that's going to tell you basically your how far like stretched your hyperbola is going to be. And last thing I wanted to mention here. So this is a hyperbola that has a horizontal transverse axis. Notice how a squared is under the x, right? Now before, a squared was always larger than b squared for an ellipse. That is no longer the case. So that's why we really need to be careful here. When you're looking at these equations, it's always a squared minus b squared, always. However, just like for an ellipse, if a squared was under x, that means you have an elongated, in this case, major axis. Well, in this case, you're going to have a horizontal transverse axis. So now my a squared and my b squared remain the same, but now you can see I have my y is over my a squared. Now what we're going to have is a vertical transverse axis. So I didn't label everything. I just wanted you to kind of see the difference here. So now you can see we have a vertical transverse axis. The vertices and your foci are all going to lie vertically. Your co-vertices are going to lie in your conjugate axis, which is horizontal. You're still going to have the same asymptotes as well that your graph is going to approach. The one I did a little bit better for them approaching here. Eccentricity is still the same thing. You can now see though, instead of adding and subtracting my A and C to the H coordinate, like I did over here, right? You're adding A and C to H because everything's moving left to right. Well, for a vertical, you're going to be adding A and C to the K value because you're going up and down, right? Dang it, I knew there was going to be something else I was going to match up. You can notice though that the difference here is the asymptote equation. Instead of the asymptote equation being B over A, like it was for the horizontal transverse axis, now you can see that it is A over B. So we do have a little bit of a difference for our equations of our asymptote. And the last thing I forgot to mention to you is our relationship between A, B, and C is different than from an ellipse. If you remember from an ellipse, A was always larger than B, right? So that was the way that I kind of remember it. C squared equals A squared minus B squared. A is always larger than B, so I just always thought A squared minus B squared. Well, in this case, since we have a hyperbola, that's not the same. The hyperbola, the relationship between A, B, and C is not the same as it is for an ellipse. So for hyperbola, it's actually just like the Pythagorean theorem. A squared plus B squared is equal to C squared. It's a little bit easier to remember. And again, you can see that A is under the Y, that vertical transverse axis, horizontal conjugate axis. Again, they intersect at the center, which is HK. All right, so let's go and get into the two examples that I would cover as a class for my students. So the first one, you can see that's already in standard form. Nice, don't really need to do anything. I recognize that whatever is my first term is going to be my a squared, right? So I could say, all right, a squared is equal to 25. I don't know why I didn't do the a below it, but you could see the a then is going to equal 5. B squared is going to be 16, so therefore b is 4. Now to find c, I needed to remember the relationship. C squared equals a squared plus b squared, so therefore c equals the square root of 41. And then let's see here. Since my a squared was under the y, I know I'm going to have a vertical transverse axis. Now, one thing you'll notice is I could put this v here. So I didn't really have enough space to actually like draw it. A lot of times, if you remember an ellipse, I like to like plot the information just so I can see that vertical. I like to plot the center and then that vertical transverse axis. I didn't have kind of space to do that, so I just put a v, and that was just to remind me that my vertices and my foci are going to be going up and down from the center. Now, another common mistake students will make here is that they'll treat the center as -3, -1. But be careful. Remember, h is always with x, k is always with y. So the center is actually -1, -3. All right. So now we have our A, B, and C. We know that this is a vertical transverse axis. So therefore, from the center, why am I going up and down? I just did those all wrong. See, you can see that this is a vertical transverse axis, right? So I should be adding my, since it's a vertical transverse axis, I should be adding my foci to my y coordinate, not my c coordinate. So I just did all of those wrong. Actually, I just did everything wrong. So let's go ahead and fix that. Wow, good thing I catch my work here. All right, so let's go ahead and do it correctly now for you. I was going to do these other problems, but you can see how easy it is to really kind of get everything mixed up. So my foci, so we're going to take the center. So I have a -1. That's not changing, right? If I'm moving up or down, the x coordinate's not going to change, but I'm going to have -3 plus or minus the square root of 41. That cannot be simplified, so I'll leave it like that. The vertices, again, are going to be going up and down as well. So I'll have a -1. And that's going to be comma, let's see, -3, and that's going to be plus or minus 5. Now here, I can simplify that, right? So I can do -1, -3 plus 5, that's going to be 2, and then -1, -3 minus 5 would be a -8. I really just wanted to redo them again, show you guys the common mistakes. Now the co-vertices, though, are going to be left and right? If the vertices foci are up and down, that means co-vertices are left and right because they're on the conjugate axis. So that is going to be a -1 plus or minus b, which would be, plus or minus 4. And that's going to be plus or minus 4, comma, -3. Okay, so -1 plus 4 is going to be a 3, comma -3. And then -1 minus 4, which would be a -5, comma -3. Okay, so there's going to be your two values there. For the next example, I'm just such a nice guy. I wanted to do another completing of the square because it still gets students mixed up. Now, this one actually is pretty tricky because you have this extra negative here. So we just need to remember when we are completing the square that we only complete the square when our a is equal to 1. So in this case, what I'm going to do is I'm going to factor out the 4. And then I complete the square, give me a 16. Here, you need to factor out a -1. You cannot complete the square here because that coefficient is -1. So you have to factor out the -1, then complete the square. And then remember, whatever you do on the left side, you have to do on the right side. Since you add a 16 here, you have to add a 16 over there. That 16 is being multiplied by 4, so this 16 needs to be multiplied by 4. You're adding 9, you need to add a 9. Multiply by -1, multiply by -1. So you got to kind of see how that works there. And then, so we have, in those cases, add those all up, you get 16. But again, remember for hyperbola, it needs to equal 1. So I divide by 16 on both sides. I get now this space. Now you can see, again, remember, a squared is always listed first. So a squared is not always larger than b squared. Okay, so in this case, a squared was larger than b squared. But notice it doesn't always work that way. It's always a squared minus b squared. Don't pick the largest number to be a squared. So a squared in this case is 4. So that means a is 2, b squared 16, b is 4. Here you can simplify, c squared. Now in this case, I wrote an h because it's a horizontal left to right. So you can see how I did this correctly because you can see my x values are what's moving, right? So, and then my y values are, actually, I didn't do the covertices. I guess I could do the covertices. I'm not going to ask my students to do the covertices, but why don't we just do them? So my covertices would be, so this is horizontal, so that means my covertices are going to be up and down. So that will be a -4, comma, and let's see, that'd be 3 plus or minus 4. So 3 plus 4 would be 7. And 3 minus 4 would be -1. So that'd be a -4, -1. Okay, but for my vertices and my foci, you can see that I'm moving left and right. Okay, so those have been the two problems I would have done with my students. And then I would have given my students, or then I gave my students 6 problems to go ahead and do inside the classroom in groups or put them on the board. So let's go ahead and knock these out. We are just going to find, what did I ask for? We're just going to identify the center, the foci, the vertices, and the asymptotes, which I didn't do. Oh, I did this asymptote. I didn't do this one. So let's go and do that real quick. So that's horizontal. So that means it's y equals plus or minus b over a times x minus h plus k. Okay, now you could simplify this. You can see like, and I actually didn't even explain that over here. So notice like, since it's vertical, here's the equation for the vertical. And now I already found a, b, and the hk. You just plug it in. You could obviously simplify this by applying distributive property. But as far as just getting the work, that is fine for my class. In this one, though, we have a horizontal transverse axis. So notice that I'm using a different equation. So in this case, we'll just have y equals plus or minus b. So that's going to be b over 2. So we'll have a 4 over 2, comma, x plus 4. And then let's see, that's going to be plus k. K in this case is 3, so that'd be a plus 3. Now in this one, we could actually simplify, right? This one's not that bad to go ahead and simplify, right? You're not going to be dealing with any fractions. So you could distribute that and, combine like terms. But do remember that is a plus or minus though, right? So you would have to do it twice. Okay, so now let's get into the 6 different types of questions I would have given my students. I put a 1 here, but I really didn't have to put a 1. Hopefully you guys recognize in this case. Let's see here. The center is going to be 0, 0. Okay, let's see here. We got a squared is 4, right? Because that's the first term. B squared is going to equal 1. And c squared is basically going to be the sum of a squared plus b squared, which is 5. So we could say a equals 2, b equals 1, and c equals the square root of 5. Now I know that my a squared is under my x, so therefore I'm going to put an h here, meaning that's a horizontal transverse axis. That means I'm going to be adding and subtracting to the left and to the right of the center. So in reality, my vertices here are really just going to be 0 plus or minus 2, right? Because you're shifting left to right, comma, 0. Now again, you don't really need to write 0 plus or minus 2. You could just write plus or plus. You could really just write that as which is equal to, which is the same thing as, 2 comma 0 or negative 2 comma 0. However, that's a little bit more writing, so I am perfectly fine if you wanted to write F for your foci. That's going to be left and right C, right? So I am perfectly fine with just using the plus or minus 5 comma 0. Okay. I'm not going to worry about the co-vertices, because they're not on the graph. So we'll just find the vertices, the foci, the center, and now the asymptote equation. Since this is a horizontal asymptote, that is going to be the only difference between the two equations. Is it A over B or B over A? For horizontal, it's B over A. So therefore, in this equation, I'll have the asymptote will be y equals, let's see, that's going to be B over A. So that's going to be 1/2. Oops, don't forget the plus or minus. So let's fix that. So it'll be plus or minus 1/2 times, and then this is x minus 0, plus 0, right? So therefore, in this case, we'll just do 1/2 or plus or minus 1/2 times x from there. Okay. Okay, so on to the next example here, where again, we can see that the a squared is going to be under the y, right? So automatically I can determine that this is going to be a vertical. Again, we are going to have a center, which is at 0 comma 0. And again, since it's a vertical, we could also write the asymptote equation is going to be plus or minus. Let's see, that's going to be a over b times x minus h plus k. So just by looking at this, we can say now that since the a squared is under the y, we know it's vertical, we can identify the center, and we can identify the asymptote equation. So a squared is going to be 16. That means a is going to be 4. B squared is going to be 36. That means b is going to be equal 6. And then our c squared, remember it's a squared plus b squared. So that's going to be a 52. And therefore you could simplify that. Let's see here. 16, or let's see, 4 goes into 10, 13 times. So that's going to be c equals 2 square root of 13. Yes. All right. Very good. All right, so we have a vertical transverse axis. That means my vertices and my foci are going to be going up and down, right? So in this case, we know that's going to be up and down. So it's going to be up and down 4 and C. So 4 and 2 radical 3. So my center is 0, 0. My vertices now are going to be 0, comma, plus or minus 4. My foci is going to be 0, comma, plus or minus 2 radical 13. Right? If you wanted to do co-vertices, I'm not asking it, but if you needed to, it'd be plus or minus 6, comma 0, because those are going to be going left and right. The asymptote equation is going to be my a over b, which is 4/3. So that's going to be y equals plus or minus a 4/3, and that's going to be x minus 0 plus 0, which again, you don't really need. So you could just do plus or minus. That's not 4/3. I was trying to simplify that. That's a 4/6, right? That's a over b. So therefore we'd have plus or minus a 2/3 x, and that'd be your equation for your asymptotes. All right, let's go ahead and continue on. Next up is the hyperbola. Now recognize this is obviously not in standard form. So the first thing you're going to want to do here is divide by 20 on both sides. Therefore, that would give me a y squared over a 4 minus a x minus 3 quantity squared over 5, right? 4 over 25th reduces to 4 over 20 reduces to 1/5. And then that's going to equal to 1. Now, again, we can see my a squared is going to be under the y, so that's going to be a vertical. We can say that the center here is going to be 3, comma 0. Let's see here. We can say my a squared is equal to 4, my b squared is equal to 5, and my c squared is going to equal to 9. So therefore, a is equal to 2, b is equal to square root of 5, and c is equal to 3. Now, again, since my transverse axis is vertical, that means my foci and my vertices are going to be going up and down from the center. So 3 is going to remain the same. I'm just going to go up and down my distance of a for the vertices, and up and down 3, my distance for the foci. So my vertices in this case is going to be 3, comma 2. And 3, comma negative 2. You could do the plus or minus. I'm just kind of switching it up. For my foci in this case, that's going to be 3, comma 3. as well as 3 comma negative 3. So you can see I'm just adding and subtracting 3 and 2 to 0, right? So that's why it doesn't really change much. Your covertices, though, would be left and right. So if you want to do, might as well just do the covertices. It's not like it's difficult. That's going to be 3 plus or minus the square root of 5 comma 0. I just wanted you guys to kind of see that difference. The asymptote equation is going to be another A over B, right? So that's vertical. Yep. So it's going to be an A over B. So it's going to be plus or minus 2 over the square root of 5. Don't need to worry about rationalizing the denominator. And that's going to be x minus h. So that'd be x minus 3. And then plus 0. We'll just leave it from there. The next one, again, if we want to simplify this, so we'll divide by a 36. Put this in your standard form here. So 9 over 36 is a y squared over 4 minus a x over 36 is equal to 1. All right. So again, we have another vertical one where, so now a squared, that's an x squared, sorry. So a squared is going to equal 4. My b squared is equal to 36. And my c squared is going to equal 40. So a is equal to 2, b is equal to b is equal to 6, and c is going to be a 2 radical 10. All right, since my a squared is under my y, again, that's going to be another vertical. So again, I'm going to be going up and down here. You can see that my center in this case is going to be at the origin. So that's going to be 0, comma 0. My vertices are going to be going up and down from there. So that's going to be 0, comma plus or minus 2. My foci are going to be going up and down as well. So that's going to be 0, comma plus or minus 2, square root of 10. And your covertices are going to be going left and right. I don't know why I keep on showing these, but either way, plus or minus, that's going to be going left or right. Remember, those are always perpendicular. All right, now into our last set, which is going to be, in this example, again, is in standard form. Did I already do? So I just want to see vertical, vertical, and then these are 2 horizontal, vertical. Okay. All right, so in these last examples, again, first thing we can do is identify our a squared, which in this case is going to be a 16. So we'll have another. So in this case, I have my a squared is equal to 16. A b squared is equal to b squared is equal to 4. And my c squared is going to equal to 20. So a is equal to 4. B is equal to 2. And c is equal to, let's see, that's going to be the square root of 20. So that would be 2 square root of 5. The center in this case, though, is again now going to be at 2, comma 1. All right. And again, since my a squared is under the y, it's going to be vertical. So we're going to be moving this up or down. So if I'm moving this up or down, that means my y coordinate is going to be what is changing. So for my vertices, that's going to be 2, comma 1 plus or minus 4, which can equal to 2, comma 1 plus 4, which is 5. As well as 1 minus 4, which would be a 2, comma negative 3. For my foci, that's going to be up and down a c value. So it's going to be 2, comma 1 plus or minus 2 square root of 5. Did I not do the asymptotes? I forgot to do the asymptotes here. Again, that's vertical, so that's going to be a over b. So that'd be y equals plus or minus 2 over 6, comma x, just comma x, right? Because they're both at the origin. So that'd be, so that's my asymptote equation. Y equals plus or minus 1/3 x. Okay, back to this equation. So I found my vertices, the foci. Let's just do the covertices. That's going to be 2 plus or minus 2, comma, what is the other? So that's 2, comma 1. Okay, so that's going to be the same thing as 2 plus 2, which is 4, comma 1, as well as 2 minus 2, which would be 0, comma 1. And then the asymptotes here, again, since my asymptote equation is going to be vertical, then it's going to be a over b. So in this case, I'll just have y equals plus or minus 4 over 2 is going to be 2 times x minus h, which would be minus 2, and then plus k, which would be a plus 1. So again, remember, it's only that x minus h is, that's why you're using that same value here. But because remember, the equation is x minus h, y minus k, right? So if I'm doing y plus k, it would be plus 1. All All right, in the last equation here, we need to put this in standard form before we can go ahead and do anything with it. So the first thing I'm going to do is I'm going to group my x's and my y's. So I'll put the x squared minus 2x minus y squared minus 4y, and then put the 4 to the other side. All right, now I'm basically going to group my two terms. So I have an x squared minus 2x minus, remember you're factoring out a negative here, so that's going to be y squared plus a 4y equals 4. Now I'm going to complete the square, so it'd be x squared minus 2x. Let's see, that's going to be plus 1. And then minus a y squared plus 4y plus 4 equals 4. So again, on this left side, I added a 1, so I need to add a 1 over here. On the left side over here, I added a 4, but that 4 is being multiplied by a negative 1, right? So when I add a 4 over here, I also need to multiply that by a negative 1. Now here, I'm going to condense my values. So that's going to be x minus 1 quantity squared minus a y plus 2 quantity squared equals 4 plus 1 is 5 minus 4, right? 4 times negative 1 is just going to bring me back to 1. Okay. So now that's just going to bring me back to a 1 in this case, which you can see now is going to be in our standard form. Now this one kind of brings in something interesting here because you can see my a and my b are both 1, right? So that's a 1 and that's a 1. Kind of an interesting result here. So let's go and take a look at how this would leak. Now again, let's see how that would change and affect things. So my a squared is going to equal 1. My b squared is going to equal 1. And my c squared, though, is going to equal 2. So a equals 1, b equals 1, and c is going to equal the square root of 2, which is larger than 1, right? Now, what that really does, though, is, again, also we can see that my a squared, though, is listed first. So therefore, we can see that this is a horizontal. That means my vertices and my foci, though, are going to be going to the left and to the right. So in this case, let's see here. In this case, this is still a hyperbola, though, because it still multiplies to give me a negative number. So it's just the fact that actually they are going to be the same, which is something possible. For if this was an ellipse, we know that would produce a perfect circle. So this is kind of like that hyperbola, though, that's going to have, if you look at the asymptotes, they're going to be the identity function. But either way, let's go ahead and figure out our center here. So our center is going to be at 1 comma negative 2. Okay, and again, my vertices are going to be going left and right from there, right? And they're going to be going left and right 1. So my vertices here are going to be, to the right one would be 2 comma negative 2. If I went to the left one, it'd be 0 comma negative 2. My foci, we're going to be going left and right, square root of 2. So that would be 1 comma plus or minus, oops. So that would be 1 plus or minus the square root of 2, comma, negative 2. All right, and for an asymptote equation, that's going to be my b over a, which is just going to be 1, right? So that would be y equals plus or minus 1 over 1 times x, let's see, minus 1, and then plus negative 2, so minus 2. So I'd have y equals plus or minus x minus 1 minus 2. Okay, so again, you can see that there's that linear equation here with a slope of 1. But you're going to have a little bit of transformations from there because you do have at least the graph has been shifted a little bit. Okay, so that was the idea. I didn't really get into the graphing of the hyperbolas because, again, all you're really doing is plotting points. You're going to plot the center, plot the vertices, plot the foci, and then you can plot the covertices, again, to create a box to graph the asymptotes. I think that's going to be a lot easier than actually having to simplify some of those asymptote equations and then graph the lines. But the next thing that we go ahead and work on is now going ahead and finding the equation of the hyperbola. So again, just like we did for a parabola, just like we did for a circle, just like we did for an ellipse, when you need to write the equation, you need to find the h, k, a, and b. Sorry. And then you need to know where's the transverse axis, horizontal or vertical. So you need to identify, is the transverse axis vertical or horizontal? And then what is the h, the k, the a, and the b? All right, so typically the first thing you want to do is plot the information. So in this case, I have a point. Great. So I'm going to go ahead and plot the point. Ooh. Okay, so I have the point 5, 3. So 1, 2, 3, 4, 5, 1, 2, 3. So there's the point 5, 3, which is my vertex. Now again, remember the vertex lies on the transverse axis. My next point is my asymptote, which again, remember the asymptote is B over A or A over B. Right now, we don't have enough information to determine which one's A, which one's B. The only thing I do have though is I do have my H and my K, right? So again, if I was to like plot this, I can now say that my center, so from this information, I can say my center is going to be at 2, 3. So I'm going to go over 2, up 3. So if here's my center and here's my vertex, that means I know that this is going to be a horizontal transverse axis, right? So the equation that I'm going to use is going to be an x minus h quantity squared over a squared minus a y minus k quantity squared over b squared is equal to 1, right? Because again, like if the vertex is to the left of the center, it's not going to be up or down. It has to be left or right, obviously. So I have the center. I got my hk. Awesome. So if it's horizontal, that means this is b over a. So now I can say that my a is equal to 2 and my b is equal to 3, right? Because a horizontal transverse axis, remember, is y equals plus or minus a over b times x minus h plus k, right? So if I need to figure out my a squared, so if I have 2, then that means that's going to be 4. So let's say it's x minus 2 squared over 4 minus, let's see, that's going to be a y minus 3 over a b squared, which is 9, equals 1. And there you go. All right, so let's go into the examples now. I believe I gave my students, 4 examples or 6 examples actually, for them to go ahead and work on. So let's go ahead and take a look at what they had to do. So in the first example, we just have 2 points, foci and vertices. So the first thing we're going to want to do is plot the information. Okay. All right, so we have 0 plus or minus 3. So over 0, so up 3, down 3. Okay, so there's my vertex, there's my foci. Now already from this point, once I have my 2 foci, I know that this is going to be my center. So I'm going to know I have a center at 0, 0. And I know I'm going to have a vertical transverse axis, right? Because you can obviously see that the foci lie on the transverse axis and those are vertical. So therefore, my equation now is going to be a little bit different than the last one I did. That's going to be y minus k squared over a squared. And then I have my vertices here, which is +1 or -1. So there's a vertice, there's a vertice. So from this information, I can identify the center because that's the midpoint. I can identify my A, which is 1, and my C, which is 3. So, and then also I know the equation is going to be y minus k, quantity squared, over a squared minus x minus h, quantity squared, over b squared is equal to 1. Okay? All right. So now we got that down. The only thing else we need to do is figure out our b. So remember, c squared equals a squared plus b squared. So c squared is 9 equals a squared, which is 1 plus b squared. So therefore, subtract 1, that means 8 equals b squared. You can square root both sides, even though the square root of 8, 2.8284271. We will just leave that to a 2 radical 2 equals b. Actually, we don't need that. Why do I do that? Because I think it's just our natural, we want to go through it. But again, remember the equation, guys. We need just b squared. We don't care about b. So in this case, I'm going to have y minus, so this is at 0, 0, right? So it's y, I'll just write it all out and then we'll simplify it. Y minus 0 squared all over 1 squared minus x minus 0 squared over 8 equals 1. And I can just simplify that to a y squared minus x squared over 8 equals 1. All right, for the next example, I have the center, the focus, and the vertex. Now, on a test, a lot of students will get confused on this one because they're not plural. They're like, oh, you have these singular things. That means it has to be a parabola. But again, like the center should kind of give you off. And a lot of times I will clarify like this is a hyperbola. So again, remember like when we talk about foci, that's because there's 2 of them. That's the plural version. But if I just give you 1, you still have enough information to figure out what the value C is, right? Because the value C is a distance to the center to either focus or to both foci. So let's go and plot the information that we have. So I have 1, 2, 3, 4, -2. There's my center. My focus is 1, 2, 3, 4, 5, 6, 7, 2. I think you're kind of getting the idea. And then my vertex is going to be at 6, 2. So hopefully you can kind of see here's the center. I think you would agree that this is going to be a horizontal transverse axis. So I'm just going to put a nice little h here. So therefore I know now my equation is going to have the a under the x squared, right? Okay. Also from this case, I can identify that a is going to equal 2, right? So from the center to my vertex is 2, and c is going to equal 3. So again, using my c squared plus equals a squared plus b squared, I'm going to have 9 equals 4 plus b squared. Okay, so 5 is equal to b squared. So I'm just kind of using the same formulas. That's why I'm not going. So I'll just write that. C squared equals a squared plus b squared. Okay, and again, you're just counting. A is the distance from the center to your vertex. C represents the distance from your center to your focus. And now we have all the information we need, right? Because remember, this is our h and that's our k. So this is horizontal, so it's going to be x minus 4 squared over a squared, which is 4, minus a y minus k. So again, y minus a -2 would be y plus 2 quantity squared over b squared, which is 5 equals 1. On to the next two. So the next two, again, I have another asymptote equation. Again, we don't know if it's a over b or b over a, but we do see that the vertices are going to be plus or minus 8. Interesting. So if I go ahead and graph those, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. From that information here, I say, oh, well, that means the vertices are going to be up and down, right? So therefore, I now have a vertical transverse axis. That means my a squared is going to be under my x, or under my y, I'm sorry. From this point also, I can identify the center is the midpoint of the two vertices. So I can say the center now is going to be at 0, 0. And remember, if it's a vertical transverse axis, that means it is going to be a over b, right, is equal to your coefficient here, which is 2. Well, I know that the distance from the center to your vertice is 8. Yes? So that's a, right? The distance from the center to your vertex is a. So therefore, I can say 8 over b is equal to 2. Therefore, multiply by 2 on the other side, right? And then divide by 2. You can say that b has to equal 4. Okay? So now I know a, I know b. I found the center, and I know it's a vertical transverse axis. Guys, I have now everything that I need. So this will just be a y squared over a, which a squared, which is, I'm sorry, I should probably write that in there. A is going to be 8, so that's going to be over 64, minus a x squared over b squared, which is 16, equals 1. All right, moving on to the next example is, again, we have 2 points, the vertices, and then we have a point. Now, again, immediately once I see that has the point, I'm just going to represent this as xy, right? Because remember, like if you just have a random point, that represents your x and your y coordinate. So my vertices, yeah, those are points on the graph too, but those are even more important because if we know the vertices, not only will that tell us is it horizontal or a vertical transverse axis, we can also find the midpoint, which will be the center, and the distance from the center to your vertices is our value a. So we can get a lot of information from these 2 points. So let's go and plot these 2 points here. So I have 2, 3, 1, 2, 3, and I have 2, -3, 1, 2, 3. All right, so again, we can identify the center here is going to be the midpoint. So the center is going to be at 2, 0. I can identify that my distance a from the center to your vertice is 1, 2, 3. So a is going to equal 3. That means a squared is going to equal 9. A squared is going to equal 9. I don't have enough information to figure out my b. But let's see here. I can tell this is a vertical transverse axis. So therefore, the equation I'm going to use is going to be a y minus k quantity squared over a squared minus a x minus h quantity squared over b squared is equal to 1. Okay. So let's go and take a look at this y minus k. So I'm not subtracting anything from my center, so that's going to be a y squared over a squared. So that's going to be 1, 2, 3. So a squared is 9. Minus x minus h, so that's going to be a x minus 2. Now again, we don't know what b squared is, right? So right now we have an unknown for y, x, and b. That's squared for the equation. However, we have this point that it goes through. It goes through the point 0, 5. So what that means is I can plug in 0 in for x and 5 in for y to go ahead and solve. So that's what I'm going to do here, actually, in this case. Let's go ahead and do that over here. So I'll put a, what was that? 5. So I'll do a 5 squared over 9 minus 0 minus 2 quantity squared over b squared equals 1. So I'm kind of moving left to right. Sorry, I ran out of space. So that's a 25 over 9 minus negative 2 squared, which is be a 4 over b squared equals 1. Now, obviously, you're going to now need to subtract this. So you can go ahead and rewrite this as a 9 over 9 if you needed to. But if you subtract that over to the other side, you'll have a negative 4 over b squared. And then you can rewrite this as equal to a 9 over 9 minus 25 over 9, right? So basically, I'm just subtracting the 25 over 9 to the other side. I'm rewriting 1 as 9 over 9, right? Because 9 over 9 is 1, right? So, but now they have common denominators. I can rewrite them. And again, we can put my point over here. So therefore, I will have a, let's see here, a negative 4 over b squared equals a negative 16 over 9. And then obviously now you can kind of do a little cross multiplication or just multiply out. We're kind of getting a little low on time here or space. So I'll just do a 36 equals a 16b squared. 36 over b squared, yeah. So divide by 16, and then that can go ahead and reduce to a 4 can divide into there. That's going to be a 9/4. Okay. Now we don't want to put a b squared in as a fraction right there. So what we can do is go ahead and write that as the reciprocal. So my final answer would look something like this. Y squared over 9 minus, instead of 9/4, we can write this as a 4 times x minus 2 quantity squared all over 9 equals 1. Jeez. A little bit more of a advanced number. I was hoping I was probably going to pick one of these like easier ones, or to do eventually one of these that would be a little bit more basic. But I guess I did not. So we'll just kind of work with that. But there you go. Okay, but that's basically the process. Instead of writing a b squared, which you could write in there, but again, just remember dividing by 9/4 is the same thing as multiplying by 4 over 9. So that's what I did. Instead of just putting 9/4 in for b squared, I just flipped it. So therefore, you don't have a fraction in the denominator. All right, let's go and get into our last two. And it's not necessary. I would probably still accept it for my students. They could have something like this, and they might, it's just something to be aware of. All right, so for the last two here, I have write the equation for the hyperbola. Now in this case, I'm given the conjugate axis. Now remember, the conjugate axis is from covertice to covertice, right? So immediately I know that that is going to be 2b is equal to 4. So b is equal to 2. Very good. And then my vertices here is -2, up 8, and -2, 2. So let's go ahead and see what I got here. So if I plot those points here, so it's going to be a -2, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And -2, +2, 1, 2. Okay. So again, we still need to kind of find like the distance here, or the kind of the center, right? Because these are your two vertices. I know B, but the center here is going to be in between these two, right? So you got to think like, what would be the midpoint? Well, that's going to be -2, 5. So -2 up 1, 2, 3, 4, 5. So the center, if you could use the formula here, center would be at -2, 5. All right. So now, again, guys, I already know the distance from the center to your vertice, right, is just going to be 3. So we could say A is going to equal 3. But now I recognize I have a vertical transverse axis. I know A and I know B. I know everything I need to know to write the equation. So I have y minus a negative 2, so that'd be y plus 2, quantity squared, all over a squared, which is 9, minus a x minus 5, quantity squared, over b squared, which is 4, equals 1. The last one is, again, we have something with eccentricity. So we still have eccentricity that was in your notes. Remember, eccentricity is c over a. The problem is that's not written as a fraction. So is it 4 over 1? Is it, 8 over 2? Like, we don't know, right? But we do have the center, which is 1, 0, and the foci, which is 0, negative 4. I don't know why I chose everything to be vertical here. Weird. All right, so let's go ahead and plot the information. I thought I would like at least mix it up a little bit. So the center is at 1, 0, and the foci is going to be at 1, negative 4. So 1, 2, 3, 4. Okay, so again, we can recognize here that we know that C is going to equal 4, right? The distance from the center to your foci is 4. Well, again, if this is C over A, well then therefore we know that A is equal to 1. So again, remember C squared equals A squared plus B squared. C squared equals A squared plus B squared. So C squared is going to be 16. A squared is 1 plus B squared. So 15 equals B squared. Well, again, guys, we already know what the center is, which is your HK, right? We know our A squared, we know our B squared, and we know that since the foci is below the center, it's a vertical transverse axis. So therefore, this would be y minus 0 squared over A squared, which is 1, minus x minus 1, quantity squared over B squared, which is 15 equals 1. So there you go. Looks like for all the problems that I had for you writing the equation, almost everything was vertical, 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 and one horizontal. I guess I probably need to go ahead and mix those up. And then the problem I did was horizontal. But either way, guys, hopefully they helped you out. Really, all you need to remember for writing the equation is to identify if it's vertical or horizontal, identify the center HK as well as your A and B, and then you're basically good to go. As far as finding the equation, again, really just make sure it's in standard form first. Make sure it's set equal to 1. Identify the center, identify your A and your B, and therefore and your C, and you can basically just plug in the information or understanding the coordinate points. I think it'd be important to graph it so you can see where everything is being moved. And just remember that your foci and your vertices lie on the transverse axis, and your co-vertices lie on the conjugate axis. But yeah, it's a lot to go through, and it's a lot to remember, but hopefully this helped you out, and please feel free to post any questions down below, and I'll see you on the next video. Cheers.